friends, this is Priyanka. Today we are going to solve a problem on stability analysis and root locus technique. In this video, we are going to apply Routh Hurwitz criterion to find out the stability for a given system. We will consider here the case when all the elements in one row is equal to 0. Let us first observe what is the given characteristic equation for a system. S cube plus 5s square plus 6s plus 30 is equal to 0. So what is the first step? So first step is the formation of Routh array. So for that we have to first plot these all the orders, that is orders for S in vertical line. So I will consider here one vertical line. Then first order is S raised to 3. So I will take S cube. Then next is S square. Then next is S. That is S means S raised to 1. And so we have to take next is S raised to 0. So this we have to plot. Now we have to take all the elements first two rows. So we have to consider here the elements or numbers from the given equation to complete these two rows. So how to take, in which manner we have to take the numbers in first two rows. So for that, first row coefficient. So for selection of the first row coefficient, we will select here the first number, that is 1. Here no number is there, that means 1. So 1s cube. Then we have to take alternate number, that is 6s, and only 6s is there. Now for the second row coefficient, we have to consider here the second number and then alternate, that is 4. So for the second row I have written with the help of red marker, and for first row coefficient I have written here with the help of black marker. So here no any coefficient, that means we will consider 1. So first row coefficient is coefficient of S cube and coefficient of S, that is 1 and 6. Then for second row coefficient is 5 and 13. Now we will move for the next calculation. Now if we move for the next calculation, I will consider here the multiplication. So I will show with the help of arrow. 5 multiplied by 6 minus 30 multiplied by 1 divided by 5. So if I take here 5 multiplied by 6, that is 30 minus 30 divided by 5. So which is equal to 0. And then here also we have to take 0. Now if we observe this row, then all the elements in this row is equal to 0. So what is the next step? When all the elements in one row is 0, then we have to consider the row above which all the elements is 0. So where is that row? That is when the row in front of S raised to 1 is all the elements are 0, then we have to consider the row for S square and we have to form the auxiliary equation. So how to form the auxiliary equation? So I will write here auxiliary equation, that is nothing but A of S is equal to. Now this is the row in front of S square. So I will multiply the first number with S square. That is 5s square, and we have to add the second number, that is 30. So I will write auxiliary equation is nothing but 5s square plus 30. So this is the auxiliary equation. Now we have to differentiate this equation with respect to S. So how to differentiate? That is dA by ds is equal to. Now here S square is there. So when we differentiate, that means it will become S square is nothing but 2s. So 5 multiplied by 2, that is 10s plus 30 is constant, so here is 0. Now here two numbers that we get, that is 10 and 0. So we have to take, instead of this 0 0, we have to consider these two numbers, that is 10 and 0. So this is very important step, that is we have to differentiate this auxiliary equation with respect to S, and whatever is the equation, then we have to select the coefficients in that equation as the numbers in that row. So here for S, that means S raised to 1 is having coefficient 10. So instead of 0, I will take here as a 10, and then next number is 0, so I will select here as a 0. So now we can move for the next calculation. So for next calculation again 10 multiplied by 30. So I will write here 10 multiplied by 30 minus 5 multiplied by 0, that is 0, and divided by 10. So here the answer will be 30. So 10 is getting cancelled and here the answer will be 30. So in this way this calculation is getting completed. Now this first step, that is first step is the formation of Routh array is getting completed, and what is the next step? To apply Routh Hurwitz criterion. So when all the elements in one row are 0, then we have to consider the two steps. That is first step, that we know that we have to check the sign for all the elements in the first column. This is the first step. But the next step is that we have to solve the roots for this auxiliary equation, and then we have to find out the roots. So first we will consider all the elements in the first column. So I will rewrite this: s cube, s square, s raised to 1, s raised to 0. So what are the elements? That is 1, 5, 10, 30. 1, 5, 10, 30. Now we will consider the sign. So sign is plus, 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 plus. So we can say that how many number of changes in sign? So number of changes in sign is equal to 0. So I will write here number of changes in sign. So there is no any change in sign. All the signs are plus, that is equal to 0. So number of poles in right hand plane or right hand side plane, that is equal to, so that is equal to also 0. Now I will show here the S plane. So we know that this horizontal axis is real axis, we will show here by sigma, and this vertical axis is imaginary axis, we will show here by j omega. Now from this we can say that number of poles in right hand plane, that is equal to 0. So what is the right hand plane? Suppose there are 4 quadrants, first, second, third and fourth. These are 4 quadrants. So first quadrant and fourth quadrant, this is the right hand side plane. So I will say here RHS, right hand side, and RHS. So when the number of changes in sign, that is equal to 0, so no any poles appears in this right hand side plane, that is no any pole is there in first and fourth quadrant. So we can say that according to this system is stable, because all the poles lie in the left hand plane. Here is 0, that means all the poles lie in left hand side plane, and when any pole appears in this right hand side plane, then we can say that the system is unstable. But according to this, here number of poles in right hand side plane, that is equal to 0. Now we have to take the second step. So second step is that we have to find out the roots for this auxiliary equation. So I will say here 5s square plus 30 is equal to 0. So s square is equal to minus 30 by 5. So minus 30 by 5, that means minus 6. So how to find out the roots? So s is equal to, if I take square root on both sides, then it will become s is equal to plus minus under root of minus 6. So under root of minus 1, that is we will consider here as a j. So remember, this is so much important point, that is under root of minus 1 is nothing but j. So I will write here, that is under root of 6j. So this is the roots, that is plus 6j and minus 6j. So these are the two roots that lie on the imaginary axis, because on this vertical line, this is the, here value is j omega. So whenever there is j, that is under root of minus 1 is there, then we have to show the roots on this imaginary axis. So plus 6j. So if we observe here, this 1, 2, 3, 4, 5, 6, and here is 1j, 2j, 3j. So we can say that any one number, that is under root of 6j plus under root of 6j minus under root of 6j. So So roots for auxiliary equation lies on imaginary axis, and that's why we can say that the number of poles lies in left hand plane and roots are for this auxiliary equation lies on imaginary axis, and answer is system is limitedly stable according to Routh Hurwitz criterion.